Have we already found evidence of Martian life? When looking for signs of life beyond Earth, the number one rule is to always have aliens be the last explanation. Try to rule out every other explanation first and prove it is not aliens. To that end, our first attempt to directly look for life on Mars produced some results that are still debated, and potentially do indicate there is life on the red planet. The Viking landers. In 1976, NASA sent twin landers to Mars as part of the Viking program. The two identical landers had an array of experiments to do one main task: look for direct evidence of life on Mars. After being heat sterilized in a giant oven, both landers were sent to Mars. The results of the life-finding experiments are tantalizing and annoying, with the debate on what they found still going on to this day, with strong arguments for and against Martian life. Gas exchange experiment. The gas exchange experiment was simple. Nutrients or water would be added to Martian soil and the evolution of gas concentrations monitored. The results found that oxygen, nitrogen, and carbon dioxide were being emitted and reduced. The samples would be washed and retested. Each time the rate and amount of gas evolution decreased. The results were interesting, but a lot of the gas evolution can be explained via simple chemistry in the soil. The carbon dioxide production likely being from oxidation of the organics and the nutrients with iron oxide. Still, it was an interesting set of results that found that Martian soil was not inert, and some argued the CO2 may have been more than just oxidation byproducts. Pyrolytic release experiment. Another experiment involved mixing Martian soil with water, light, and a simulation of the natural Martian atmosphere, with an enrichment of the radioactive isotope carbon-14. The samples would be incubated with the water, light, and Martian air for a few days, followed by the samples being heated up to 600 degrees Celsius. If plant life existed within the soil, it would be incorporating the carbon-14 into its biomass, and upon being baked, the carbon-14 would be released and measured. The experiment would then be rerun on pre-pasteurized Martian soil as a control. If a positive result were to happen, the test series would be run again. The first results from Viking 1 indicated a positive result, a small but not insignificant accumulation of carbon-14 in the soil, with the sterilization control showing none. This was a potential sign of biological activity as something was affixing organics to the soil. Other factors, such as water vapor inhibiting the process, and Viking not finding organics on Mars at the time, led many to believe it was actually chemical in origin. Later spacecraft have detected organics on Mars, and has given us a better understanding of Martian soil chemistry, reopening the debate as to the nature of these results. Labeled release experiment. This is the most tantalizing experiment, and one of the most often debated. The label release experiment was similar to others. Martian soil would be incubated after being introduced a dilute nutrient solution tagged with carbon-14. A detector would measure CO2 released using the carbon-14 if the nutrients were being metabolized. The nutrients were a mix of simple organic molecules, two of which had both the left and right-handed versions, in case the chirality of Martian life was different to that on Earth. The nutrients were formate, glycolate, glycine, D-alanine, L-alanine, D-lactate, and L-lactate. Both Viking 1 and 2 registered positive results immediately. This was a shock as the first two experiments registered interesting but nebulous results. The first test used surface soil, so a second series was run, this time using subsurface soil. Positive result. It was thought the results were chemical in origin, so a control experiment was run. Martian soil from the same spot were heated to 160 degrees Celsius for 3 hours, then tested. Negative result. Whatever was in the soil that broke down the nutrients was destroyed by heat. Suspecting a chemical volatile might have been responsible, more samples were heated to just 50 degrees Celsius for 3 hours before being tested, too low to destroy a chemical catalyst in the soil. Negative result. There was a small detection, but it was greatly reduced, indicating whatever was in the soil was very temperature fragile. A third series was conducted later using soil that was stored in the lander at just 10 degrees Celsius in the dark for several months. Reduced result. There was still a small positive, but like the low heating samples, it was greatly reduced despite no heating, so whatever was in the soil also appeared to be destroyed by prolonged darkness. These results are startling, and at first glance look conclusive. At the time, due in part to the lack of organics found, the results were eventually deemed not evidence of microbial life. There are also factors that back up the idea of it being chemical in origin and not biological. In a dry, cold carbon dioxide environment, UV light can produce superoxides, salts containing the ion O2-. These oxides would break down with heat and would account for the release of CO2 from the nutrients. Moreover, subsequent additions of nutrients produce declining results as opposed to increasing, as would be expected with microbes. For people like me, this is sad, a seemingly slam-dunk example of alien life snatched away by chemistry. But not everyone is convinced. These superoxides are very volatile and would be destroyed in the soil rapidly. The odd time delays with the reactions also seem to follow similar patterns to the circadian rhythms seen in cyanobacteria. According to some, further analysis of the results has also given a stronger indication that more than just chemistry might be at play here. Conclusion. So, did we find life on Mars? As I said before, it's annoying, because the best answer I can give you is, I have no idea. Most likely no, but there is enough data supporting biotic activity that yes is also a real possibility. Since Viking, there have been many missions sent to Mars, none with the same level of sterilization as Viking, both landers and crashed orbiters. Every mission increases the chances of contamination and reduces our chances of finding native Martian life. The Viking experiments are both our first and our last examples of direct life finding on a pristine, uncontaminated Mars. Although Terran life is unlikely to be able to survive the toxic perchlorates in the soil, unfiltered UV light, and brutal cold, life still finds a way. The door for us to go back and conclusively run direct life finding is closing. Once humans set foot on Mars, the chances of contamination skyrocket, and the doubt for any microbes found increases. You can't sterilize a human. So maybe it's better to send direct life finding to Mars before we send humans. Racing to build a colony on Mars might forever destroy our chances to answer the age-old question: is there life on Mars?